Okay, I'm gonna first show you how I would square up one bale. We've got a bunch of tools here. I'm gonna have you guys practice with these. These are, this is just expanded metal lath. It's just like a great big rasp, and it works really well to just do a nice trimming. I would do more than that. But you have a choice on your job site to either have a quiet job site that fits really well with a bunch of people working, with children and old folks and stuff, or you can be using power tools. So just be conscious about what do you want out of that. Do you want people to be able to chat and socialize while they work, or do you want a bunch of loud noises and and stuff?
This costs $4 or $5, maybe up to 14 if you buy the real fancy model. It has an on-off switch, so you can turn it off to lather up, to soap up. Fantastic little device. Man, oh man, this thing performs. And talk about performance. This little puppy, costs you maybe $15 at the very most. You buy a really high-end one. It'll save an average family of four up to $250 a year in energy bills. Now that's a lot. I mean, if it only sold even only saved you $150 a year, that's a pretty tremendous return on investment. Imagine if your stock portfolio, your retirement fund performed, half as well as this. We'd be all billionaires. So now there's a company that produced this wonderful little product. We can pass that around. This uses about 1.9 gallons per minute, available everywhere.
And now we're ready to take the globe and put it over top. So the globe actually mimics the curvature of the Earth. That's how we're able to see a snapshot of everything that's going to happen for the entire year in one glance. Okay, so we snap this over top, right, and then we're going to see reflections from anything around us that would actually shade this particular site. Okay, and they gave us some little slots here in the side. This actually comes with a little sort of a wax crayon pen, and we can trace out the shading that we see. That's one way to do it. It's not my preferred method. What I like to do is when I have this set up at a site, I just like to come over with my digital camera and just shoot a picture, right? And now I've captured that for that site and I can move around. So what we do then is to read this, we're going to want to be standing directly over top of the unit and looking at it, right? It can't be, from the side or from the front or whatever. You want to be standing directly over it. It actually works best on a somewhat overcast and cloudy day.
I call this kind of the olive loaf type cell. I mean, it's got a lot of different things showing in it. No two cells are the same. Some people like it, some people don't. There's these anodized aluminum frames that are nice and colored in a little dark color. It heats up the module a couple of degrees, but it's not a real issue. They're designed to take that temperature increase, A little temperature drops the performance a slight bit. It can be significant. We'll talk about this with mounting, how we don't want to ever stop air from flowing off the back of these. And we talked about strategies that maybe you could use water to take the heat off of this and heat hot water, and all these things are engineeringly possible. That doesn't mean they're a good idea, but it is possible to do all that stuff. But think simple, think clean, and I think the aesthetics really do matter. So if you like the single crystalline type of structure or the polycrystalline or that thin film type of product, they're really all available. They all work just about the same. They have little slight advantages, disadvantages, depends on your particular application.
So what's going on here is this is a moisture protection for the bales when you have a roof that's coming in right and abutting a interior or exterior bale wall. So the bales will go up past this piece of oriented strand board. On the outside of this, there is roofing felt that comes up pretty high, about 8 inches, so that any snow that's sitting here on the roof will be held away from the bales.
Most people aren't building straw bale yet out of necessity. It's based on intention, and I think for us now, intention has to be the mother of construction. We have to be choosing the way we do construction based on our intention. If it's our intention to move the planet towards greater sustainability, then we have to think about how we build.
What we need to look at is looking at high performance buildings, and high performance versus high tech. We have this cultural bias that high tech is where we need to go, and what we really need is appropriate technology, which is really the lowest level of technology that gets it right. And it's not necessarily high tech. Natural materials can create extremely high performance buildings, and they're often the level that is appropriate. It's the lowest level, and we still can create very high performance buildings. The R factors in straw bale walls somewhere between R35 and R45. That creates and not only the R value is that high, but they actually perform even better in reality. They're very, very tight, highly insulative, and then have a lot of mass. So if you design a passive solar house that's a straw bale house, you use other earthen materials, natural materials for a lot of the mass inside. Maybe you have a half wall of compressed earth blocks. That's a dividing wall that the sun shines on in the wintertime. That can create a very high performance building using appropriate technology.